Welcome to the very first episode of the new series of Math Magic called Calculus Begins. Now in this series we're going to tackle about the most difficult and the most confusing lessons that we're going to learn in grade 11. Now, in grade 11 we're going to have a total of 5 math subjects. Wait, what 5 math subjects are we going to learn all of those? No, actually we're not going to learn about all of those, but we're only going to tackle 1 of those, 4 of those, but not 5 of those. Because since we have many strands, we have here STEM, we have GASP, we have UNS, TVL, we have ABM. They tackle different math subjects. There's actually a strand that takes only 1 math subjects. Then there are some that would tackle 4. But there's really no possibility that 5 math subjects. Perhaps I didn't put the 5th math subject here, that's business mathematics, because I didn't tackle about business mathematics when I was in grade 11. And the ones I tackled were just this. We have here pre-calculus, basic calculus, general mathematics, and statistics, and probability. Now, in pre-calculus, the major lessons that are going to be under this subject are analytic, geometry, series of mathematical induction, and trigonometry. Now for analytic geometry, we're going to learn about conic sections. I'm going to say conic sections since in the word itself, cone, we can form here circle, ellipse, parabola, and hyperbola. But I'm going to expand more of that explanation later on. Now, in that conic sections, the analysis regarding these conic sections would not require you or would not actually ask you to solve. There's no solving in the analysis of conic sections. But if we would tackle about each conic section, if we would tackle about circle, ellipse, parabola, and hyperbola, that would use solving. Now for series of mathematical induction, we're going to tackle here about the lessons that you have actually learned in grade 10 and in grade 8 or in the past levels. Those are the arithmetic series, geometric series, arithmetic sequence, and more. We're also going to learn here about the binomial expansion using the Pascal's triangle, which we have also learned during grade 10. It's just that here in reading grade 11, we make lessons more complex. Now for trigonometry, if you guys have learned Sekotoa in grade 10 and grade 8, then we're always looking for the hypotenuse in the 2 legs. Well, here in grade 11, we're going to learn about the unit circle. For the unit circle, we're always going to tackle about that pi symbol, and then more and more. Now for general mathematics, we have here 5 major topics. And those are functions, then rational, inverse, exponential, and logarithmic functions. Now, under functions we have here domain and range, and then the sum, difference, product, and quotient of functions. Then for rational functions, we're going to use cancellation and then more of multiplication. Then the inverse functions, we are going to find the inverse of a specific function. That means we're going to find the opposite of the value of f of x, and that is f raised to negative 1. Now for f of x, we have here 2x plus 1, and then when we find its inverse, we have here x minus 1 over 2. Now for exponential functions, it is really fun to have this lesson because you're going to solve, especially for this one, 2 raised to 2x plus 1 equals 2 raised to 3 multiplied by a quantity of 4x plus 2. And then right after that, you're going to check it if your answer is correct. Because this equal sign right here is actually a condition. It's a conditional statement. Aside from having that equal sign, we're also going to have the greater than or equal to, less than or equal to, and more. Now, here in the logarithmic function, you'll see here this thing. Well, I'm going to read it. The logarithm of 343 with a base of 7 equals 3. We're going to tackle more of that in grade 11 in this subject. Now, for basic calculus, we're going to tackle about limit laws, plus other lessons regarding limits. And then we will have here the derivatives and the antiderivatives. Under derivatives, which is also called the differential calculus, we will talk about the rules, and then the rules for trigonometric function, exponential, and inverse trigonometric function. And then for antiderivative, which is also called integral calculus, we're going to learn also about its rules, and then the rules for also for trigonometric function, exponential, and inverse trigonometric function. Alright, now for statistics of probability, we're going to have here the random variable and discrete probabilities, wherein we're going to find the mean and the standard deviation. And then the normal distribution, wherein we're always going to talk about the z-score. And then the sampling distribution, then estimation parameters, wherein we're going to tackle about the point estimated proportions, then the t-test, and the p-hat and the q-hat. Now, as you can see, I really didn't explain each of the lessons. Why? Because we're going to tackle them in this series of Math Magic. So, with finishing my overview, then let's now move on to the first topic that we're going to have when calculus begins. That is the conic sections. So today we're going to have conic sections. So what are conic sections? Conic sections are actually curves or sections made by the intersection of a cone and a plane. The cone and the cone that I am talking about is the double right circle cone. How is a double right circle cone formed? Once a straight diagonal line and a vertical line meets together at a fixed point, and when the straight diagonal line rotates about that fixed point, we can obtain a surface which is called the double right circular cone. Now, as you can see, the double right circular cone is actually two cones which is joined together by a fixed point which is called the vertex. This is the fixed point, the one that as you can see, you would think that it actually holds the two cones together. Now, the double right circle cone has a circular base which is 100, and the perimeter of this circular the perimeter of the base is what we call the directrix. Now, the straight vertical line is the axis, and the diagonal line is what we call the generator. The axis is always a vertical line which starts from the center of the base to the vertex. And then the lateral surface of the cone is what we call the nap. There are two naps. The one above the vertex is what we call the upper nap, and the one below the vertex is what we call the lower nap. Also, the angle between the generator and the axis is what we call the vertex angle. So this is the vertex angle. Now, this is very important for you to learn because we're going to use this later on as we tackle about conic sections. We just tackled here right now about the formation of the double right circular cone. So what is a plane then? A plane is any flat figure, just like my tablet. Now, we're going to intersect this tablet on the double right circular cone, and we're going to make the three main different curves, and those are the ellipse, parabola, and parabola. Alright, so how do we form an ellipse? Right. Now, with this plane, I am going to intersect this with the double right circular cone. I'm only one nap of the double right circular cone. So, once I would slightly tilt this plane, and I would draw the angle it has made. Say that. And then we can conclude that the angle below the vertex is less than the angle above the vertex. And you would see that I have actually also made a curve with that intersection I made, and that is the picture that you can see right now on one side of the video. Now, once we would actually make this plane be perpendicular to the axis, that means it would actually cross the axis in a straight horizontal line. We can form a circle. So hence, we can conclude that the circle is a special type of ellipse. Now, how do we form a parabola? To form the parabola, all I have to do is just to tilt once more the plane, but making sure that the angle above the vertex and the angle below the vertex is exactly equal to each other. And the curve I made is right in the photo. Now, how do we form the hyperbola? If the ones a while ago are just made by only using one nap of the cone, with the formation of the hyperbola, we need both of the naps in order to form it. Now, if the parabola is an open curve, hyperbola is also an open curve. Now, when we refer to open curve, that is the way it shapes like this. Now, the hyperbola is two open curves made by the intersection of the plane in both naps. And this means that in the hyperbola, the angle above the vertex is actually lesser than the angle below the vertex. Now, with these three conic sections that we made, it did not meet the vertex. It means that we use one nap of the cone, isn't it? Now, what if I would intersect this plane to the vertex? We can form a point. We can form a point, and then my parabola will become a line, and the hyperbola becomes two intersecting lines. Now, that point, line, and two intersecting lines are what we call degenerate conics. So that's how easy it is to understand conic sections. If you guys have any questions regarding calculus or anything I didn't explain clearly, you guys can ask them right now in the comments below. If you guys have any suggestions, any lesson suggestions regarding calculus, you guys can also suggest them right now. See you again in another episode of Calculus Begins. This is Enrique telling you to stay safe and keep following Math Magic.